we'll make a start then. Evening, everybody, and welcome to tonight's Whitechapel Lecture, part of our series of occasional lectures looking at materials in the modern world. Tonight we have Mark Jolly, who will be talking to us about transforming the materials agenda for a sustainable planet, the opportunities and challenges that presents at the moment, and particularly at the moment, I think we're all much more aware of the materials that we use, not least because of activities in certain parts of the world that are making trading in some of these materials particularly challenging. I'm very pleased to that we've got Mark presenting tonight. Many of you will know Mark actually started out in the industry working to develop one of the early software simulation packages, Solstar, with FICME and then the University of Birmingham, before then moving on to Cranfield University. He was very involved in the Transforming Foundation Industries work there, and particularly the Transfire project, which was a cross sectoral and cross industry, cross university, across the whole of the UK, really, collaboration. And for those of you who aren't aware, the Transfire and Transforming Foundation Industries is looking at those foundation industries and trying to make them more competitive and sustainable. And metals is obviously a key part of that, but also cement, glass, ceramics, paper, and bulk chemicals. So he's an ideal person to be talking to us tonight about the challenges of materials. I would remind you that tonight's lecture is being recorded. We're very grateful to Eloise, who is back at the ranch making everything happen for us. So as I say, the lecture is being recorded. So what we'll do is we'll hear the lecture from Mark, and then at the end, if there's time, we'll have a few questions. So keep your questions till the end. I think you can probably put them in the chat, but we'll just open up the mics towards the end, and you can ask your questions directly if you're prepared to do so. So without further ado, I'll ask Mark to share his screen. Thank you all for joining us, and so without further ado, I'll hand over to Mark.
Thanks very much. I'm hoping everybody can see the screen.
Yeah, that looks fine, Mark. Thank you.
Perfect. So I am actually going to base tonight's lecture largely around results of Transfire, because I think it's through that vehicle that we can see what the challenges are, and of course some of the opportunities. So it is essentially based on a final report that came out in December, and there were many people involved in producing that report. Some of the names that you'll see today were the collaborators, but there were so many people involved, I probably won't be able to include everybody's name. So I apologize if there's anybody I didn't mention. So this is my agenda and the content of what I'm going to talk about. I'm going to sort of give you a little bit of a history lesson. What are the foundation industries? Pam's already mentioned roughly what they are, but I've got a little bit more detail on those. And then what Transfire, which is Transforming the Foundation Industries Research and Innovation Hub, actually managed to do, what it was, who we were, how we did what we did, and then give you some of the results. Some of them in terms of what the work streams were, and also some case studies from industry. So let's many prime ministers ago, in the heady days pre-COVID, but post the Brexit referendum, on the 27th of November in 2017, the then Business Secretary, Greg Clark, announced that there was a flagship industrial strategy for the UK. Who knew it? With a plan to boost the economy, build on the country's strengths, and embrace the opportunities of the technological changes for 2030. there were a number of what they called sector deals, which were for construction, artificial intelligence or AI, automotive and life sciences. And they were to help these sectors grow and equip businesses for future opportunities. But at the same time, there was also the launch of what they called the Industrial Strategy Challenge Fund, the ISCF, which was valued at £725 million of investment. When this was launched at the same time, Jürgen Meyer, whom I'm sure many of you will have heard of or seen on Question Time or heard on the Today programme, who was then the CEO of Siemens UK and actually is an honorary graduate of Cranfield University, said, by working in strong partnership with national and local government, we have created a very positive example of industrial strategy in action for the offshore wind industry in the Humber, which is creating a new and vibrant local economy. So he was saying that the industrial strategy was helping the area in which he worked, which was largely from Siemens Power. And now, of course, he's head of the current government's Great British Energy Project. So it was very well accepted, or very well accepted by industry and by universities, in fact, and generally around the country that we have an industrial strategy. And they developed 3 waves of challenges. So they asked industry to come forward with ideas as to how to move forward. And these 3 challenge waves were basically led by civil servants in the government. In July 2018, I was approached by Innovate UK by Ben Walsh, who was a civil servant there, to look at what was being called the energy intensive industrial processes. So, and there were some workshops, and they were basically focusing on steel, ceramics, glasses, chemicals, and cement. So on the list at the meeting were EPSRC, that's the Engineering and Physical Sciences Research Council. There were trade associations. There are 3 other academics, all colleagues I know very well, namely Julian Allwood from Cambridge University, Kerry Kawan from Warwick University, and Mark Rainforth from Sheffield. Very much materials oriented, of course. So, well, my main inputs to this particular workshop was to say that they've got their content wrong and that actually they should be looking at other areas. So they should firstly also include aluminium into and call it a sector called metals rather than just steel. And they should also include paper, because I knew from discussions I'd had that these 2 sectors, although not necessarily very large, also actually have quite a high carbon impact per kilogram of material that's produced. Certainly aluminium is huge. And also a very large amount of CO2. So in the 3rd wave that came, the Transforming the Foundation Industries Challenge was successful and aimed to support the development of innovative technologies, collaborations and investments in the foundation industries in order to increase competitiveness, secure jobs and reduce environmental impact. And as Pam mentioned, the 6 sectors were cement, glass, ceramics, paper, metals, and chemicals. So I just wanted to talk about the successful Transforming the Foundation Industries Challenge, how it was put together. So essentially, this is showing the different funding streams or the different streams of input. So from BAYES, there's a BAYES program, so industry money. And then there's the Transforming the Foundations Industry Challenge, and then there's university research. So it's sort of a horizontal stream of research and development. And then the funding came from various mechanisms. So you can see that we have the hub, we have a network, we have KTNs, that's knowledge transfer networks. We have skills, all aimed at trying to transform. So it's a really complex mechanism. And the funding was through various tools to deliver the results and to outweigh the sum of the parts, connect across sectors and connect through academia and research and trade organizations, research and technology organizations, and to solve the challenge that were common to all the industries, and then transforming the sector through leadership and cross-cutting activities. So there was a very clear message that anything that was developed had to be cross-sectoral and had to not just focus on one particular sector. So the challenges needed to be cross-sectoral, which is really interesting, because the question that we get asked is, why would the steel industry talk to the paper industry, for example? What can they learn? What can the ceramics industry learn from the cement industry? So this was put together. The UK foundation industries of the that we mentioned, that these are the industries that produce 75% of the materials that's used in the UK economy. Its value of about 52 billion, and it also creates about 10% of the CO2 footprint of the UK. So quite a chunk. So if that can be addressed, it could be significant in the challenge of global warming. So on the 8th of July 2020, the UKRI, or the and EPSRC, launched what was called the Transforming the Foundations Industries Research and Innovation Hub call, with an intent that that academics were to submit in August 2020. There was an outline in September 2020, and if successful, then we had to have a full proposal by the 1st of December. And this was for a £4.7 million grant, equivalent to about 5.9 million pounds of project. And then if you think about this, is because the government, when they put together a research proposal, they only fund 80% of the costs. Now, not many people might know that. If you're in academia, it's one of our gripes that you put in a proposal that's fully costed, and then the government only gives you 80%, which is why we wanted to get some equivalent match funding from industry to support this. Well, put your minds back to the summer of 2020. Where were most of them? I think probably in our bedrooms, in lockdown, or maybe not in our bedrooms, maybe in our living rooms, but certainly lockdown. Some people were furloughed. Unfortunately, some people were in intensive care, and certainly we're in the middle of a global pandemic. So the government launches a call right in the middle of a global pandemic, and we're supposed to put together a collaborative program across industry and university. Well, thank goodness for Teams. That's all I can say. Well, that's what I was using. I wasn't using Zoom at that time. I was using Teams. And I put together a group of industrialists and academics, which covered what I felt was the whole of the materials sectors, and all of these material sectors. I had technology people from across each of the materials sectors. I had people who understood about manufacturing. I had business people from business schools. I had social scientists from social science departments in universities across the UK. And I had environmental technologists involved as well. So a sort of social science people, but with a technology background. So quite a challenge of the numbers of people. And I obviously had industry. I had people from the sectors that I knew, but also were introduced to me by some of the other organisations, some of the other academic organisations. Well, we made our proposal, and on the 1st of February, I got the news that we'd been successful. I wasn't allowed to tell anybody, which is the normal process with EPSRC. Don't share beyond your organisations at this point. And I thought, well, who are my organisations? Well, I sent it out. I sent the news immediately out to 61 people, because there were so many people involved in setting this up. I sent out an email to a lot of people, including Pam. So Pam got the news very quickly after we got the funding, because the Cast Metals Federation, where she was CEO, were key members in helping me put together this support, the support from industry. So what was the Transforming the Foundations Industries Research and Innovation Hub that we proposed? Well, as I said, it was this big project of about £6 million, but only funded to £5 million roughly. And then it was for 3 years initially, from July the 1st, 2021, and had 12 research organisations. You can see them all there: Cranfield, Bangor, British Geological Survey, Cambridge, Cardiff, Durham, Edinburgh, Exeter, Leeds, Northumbria, York, and Sheffield Hallam. And then at the end of the program, when we started, we had about 60 companies, 60 organizations. By the end of the program, we had more than 100 project partners from industry and government and trade associations. And that was our logo. And of course, we covered all these sectors. Now, I just wanted to tell you that what was our vision. So our vision was to create this proactive, inclusive research and driven hub supporting the industry to generate more value from less resource and make better use of waste and byproducts. And we brought together the foundation industries and their stakeholders, so the supply chain as well as some end users through this interdisciplinary research. We were looking at supporting their productivity, their competitiveness, but also had climate action and equal opportunities for people and communities. So that's how we aimed to and started to facilitate the transformative change within the foundation industries. So this was our governance setup, which is also very important when you have such a large fund of money and you have so many stakeholders. So we were driven by 3 work streams, which I'll talk about in a minute. So we had 3 work streams being led. We had technical working groups for each of the sectors, which were led by the various universities named on that chart. Then we had we obviously had an operations group which met weekly. We had a management group which met monthly to look at the finances and HR and all sorts of other aspects. And then we had a stakeholder steering group which involved industry, was chaired by John Bolton, who was ex-Liberty Steel. I'm sure many people have heard of John Bolton. He's a fellow of the Institute of Materials, Minerals and Mining. And then we also had the industry leads and various academic leads and the PEIs involved in this. So this is the Institute of Minerals and Mining, Materials, Minerals and Mining. We then had a foundation industries forum where all the industry players could join with all the academic partners, which was held once a year. But we also had an advisory group, which was international, coming from all of the industries across the world, from academia and from industries across the world, being chaired by Paul Booth, who's well known up in the northeast of England as an ex-chairman of the North of England Process Industries Cluster, NEPIC. So this steering group had industry partners, government partners, and academia. So EPSRC, UKRI were represented, representing government. We had industry and we had academics. So quite a challenge to actually manage all this. And I, as director of the whole program, managing this very complex set of organizations and people was quite a challenge, to say the least. But we got there. I just want to talk about the work streams. So we developed 3 work streams in our proposal. One of them, the first one, was called Transferring Best Practice, or aiming for Gentani. Now, Gentani is a Japanese word which basically means making something with the least, essentially, briefly translated, means making something with the lowest possible resource necessary. So it's a sort of physics-based, what's the lowest amount of energy, what's the lowest amount of material, the least amount of emissions, and if you get to that ultimate point, the optimum point, that's sort of what they call Gentani. Well, it's very challenging to get there with most processes, but that gives you a flag in the ground as to what is achievable. The second one was called Where There's Muck, There's Brass. Now, I don't claim credit for that name. Anybody who's about my age might have remembered there was a soap on TV called Where There's Muck, There's Brass. Of course, it was about rag and bone men, I think. But this is essentially about driving industrial symbiosis. So looking at where raw materials can be made from waste materials, where we stop calling stuff waste, but actually we call things more of a byproduct, and we end up with using the materials better and using the resources better. And the last one we called working with communities to understand the importance of these industries within society. So what was our aim in terms of the transformation journey? I mean, before I go on to the outcomes of transfer, we have to look at what we mean by transformative change. I mean, ultimately, we need to move away from what we call a linear production and consumption system, which means you dig stuff up, you transform it, you make something, you sell it, and then you throw it away. That's a linear process. And we have to move to a more circular materials model, often understood as or called the circular economy. So we have to look at the industries and help them reform by minimizing the resource use in the manufacturing processes, and then perhaps by using industrial symbiosis, where the wastes and byproducts from industry are used as the raw materials. These give us a large number of technical challenges that, if we solve, can substantially improve the current models of production. But the essential question in reforming the industries was, how can we reduce the impact of current production models? And that's a really big challenge. If we want to actually get to true sustainable, and so if we look at this graph, you can see the first one is the linear wasteful system with lots of CO2 as well. What we wanted to move in Transpire was to get this more circular. So we have this, whatever is a byproduct comes back into the system. But ultimately, in the end, this is where we want to get to, which is more value from less resource. Because we need to think about how we are consuming and can our needs be met with less resources while generating more value for people and the environment and the economy. Because there's not enough resources to satisfy the current global population's need using the current models. We're using the way we're using our current materials and the current models that we use for manufacturing and for our business models. We would need almost 3 Earths to satisfy the global population's needs, to bring us everybody up to the same quality of life that we currently have in the more developed countries. That's obviously an impossibility. We don't have 3 planets. We need to move away from this wasteful use of materials. Yesterday, I spent all day at the Shard at a workshop developed, being driven by Warwick Business School, looking at circular economy in materials, which was attended by about 60 people. So the only topic was the circular economy. So this is something that is getting a lot of traction and is again something that maybe we should have another Whitechapel lecture on, the circular economy itself. So I'm going to now go into some of the outcomes from Transpire and looking at the work streams. I'm not going to talk about all the case studies. We did many case studies, and they were completed in by the end of the 3.5 years of the program. We actually got an extension and finished in December in 2024. So it only finished 6 months ago. And at the end, the numbers of case studies were massive. And it wasn't just about academic papers. These were case studies of things that were worked on with industry, with real industrial outputs. So I just want to talk through the work stream 1 and some of the outputs there. So this objective for this particular part of work stream 1 was to provide a clear understanding of the industry, to the industry, so all of the foundation industries. Where are we? What's the potential to improve performance and become more sustainable? So we need to identify what's being manufactured in each sector, quantify the energy and materials, resources being consumed, and then assess the current performance and determine the potential for improvement. Well, seems like an easy thing to do. Well, it's pretty complicated. So our first thing to do is to map the resources, map the energy and materials flows in each of the sectors. and at a process level. And then to benchmark. Well, benchmarking is challenging. Do we do it against global averages? Do we do it against UK averages? Do we do it against EU averages? Well, we did a number of those, and then we had to look at what the best practice was in each sector and each area. We had to develop some KPIs, and then we wanted to look at material circularity. And material circularity is a real challenge because there's no standard. So we had to develop or use what had been developed by some of the researchers involved in this program. So for each sector, we couldn't do 100% of each sector because it's too challenging. There are some very small parts of each sector. So what we did was we looked at only the materials that made up the bulk of the production in the UK, with the exception of the chemicals industry, where we excluded fertilizers, which we didn't feel was useful for a program that was aimed at materials rather than chemicals that go on to help produce food, although it's a very large part of the chemical sector. So you can see what we did with cement. We looked at obviously cement. With ceramics, we looked at refractory materials, household ceramics like bathroom ceramics and kitchen ceramics, tiles for roofing, and things like bricks. Chemicals, we looked at ethylene, ammonia, propylene, and BTX. And with glass, we looked at both container and flat glass. So the container industry, so bottles and things like that, flat glass, and then filaments for fibers essentially, so fibers. Interestingly, with metals, we looked at obviously aluminium and steel, but the third biggest sector was actually was lead. So we looked at that, and then for paper, we divided the sector into graphics, packaging, sanitary, and others. So this is now becoming quite challenging. This is the sort of methodology you can see here. So here you can see that what we wanted to do was take the raw materials, the recovered materials, what was going in terms of energy at the bottom here. So the energy, and then we've got emissions at the top there. And these are the results. So this is the whole of the foundation industry. It's not very useful. Well, it is useful because it shows you what we're doing, where the energy comes from, what it ends up as, where the materials come from, and where they go to. So some of these are water, some of it goes into materials, some of it it literally goes through the system. So water itself flows through the system, and then you can see the changes that go on as it goes through the processing. Here is the same chart, and what we can see is that we look at the emissions on this side. This is the material going in. We've got oxygen going in, and then we have emissions coming out. So oxygen going in, and then we've got carbon dioxide coming out. We've got fuel here, different types of fuel, whether it's sustainable, whether it's fossil fuel, whether it's nuclear, and then we've also got again the flow of materials going through the system, the biggest flows of materials, and this is for all of the foundation industries in sum. And there they are in the individual sectors. So we've looked at all of the individual sectors and then summed them together to get the final results. I'm not going to go into these in any detail because obviously this is far too complex, but there is a report, and we will be able to publish the location of where you can find that report, so that you can go into this in more detail. So the interesting thing is, of course, so what is the outcome? What's the final summary of this? So if we look at the final summary, you can see that for the cement industry, we have 9 megatons of materials going in. We produce emissions of 6.7 million tons of carbon dioxide, and it uses 34 picojoules of energy. The ceramics, you can go through the chemicals. The interesting one is for us as the founders is looking at the metals. we're using 7.8 million tons of materials, or megatons of materials. The look at the CO2 is producing 9.9 million tons of CO2. And look at the energy usage, 115 picojoules of energy. Now, of course, this was prior to the closure of a few of the steel blast furnaces, or sorry, not steel blast furnaces, they're not steel blast furnaces, of course, they're pig iron blast furnaces in Port Talbot, and also the current situation at Scunthorpe. So these figures will be different, the energies will be different, the amounts of materials that are being produced may be different, and of course the emissions will be lower. But it's a challenge. And if you look at the whole of all of the industries, you can see we add them together. We've got 33 megatons of materials, 330 picojoules of energy, and producing 27 megatons of CO2, of which 47% comes from the processing and 53% comes from the energy. So, if you look at it in terms of the whole of manufacturing, it's 45% of the materials footprint of manufacturing, 37% of the CO2 emissions of manufacturing, and 39% of the energy of manufacturing. And in terms of the whole of the UK footprint, you can see the figures here, 5%, 6%, and 6% for the energies. So it's not as big as the original figures from UKRI were actually saying, or at least in our estimation. We then looked at benchmarking and best practice, and what we did is we compared the UK with global averages in terms of CO2 for each sector and in terms of energy. And again, I'm not going to go into this in any great detail, but just to demonstrate that you can see there are some massive challenges, that we're not all at best practice. All the UK industries are not necessarily at best practice. Largely, in many cases, we're better than the global average, but not in all cases. But that's not really surprising, because there are some dreadful players globally. And if our aim was to be as good as the global average, then that's not a very good aim, because there are some dreadful performances globally. So what we should be aiming for is to be better than best practice in all cases. In some cases we are. So in chemicals we're doing pretty well. In cement we look to be not too bad, interestingly. And then, sorry, I should say in the UK we're not as good as best practice globally generally, but we're usually better than global. But we aren't in cement. Most of the sectors are better. Chemicals, not so good in terms of CO2. Sorry, in terms of energy. So it's an interesting mix. Just because we're using better in CO2 doesn't necessarily mean we're using energy in the right way. So it's quite an interesting challenge, that people say, oh, we're using less energy than the average, but actually producing more CO2 sometimes, or the other way around. So if we look at our potential for decarbonisation of these industries, then we can look at these are the potentials by decarbonising by using best practice, and then by decarbonising by using cleaner fuels. And these are the potentials. So in terms of the process, the clean fuels, we can get 100% best 52% reduction. It's all in the process side. And in best practice, you can see that we can reduce by 15% with these parts. So if we move on, we now need to say, well, how circular are our industries? So what's the material circularity? And now circularity depends on the type of material, depends on the energy differences between the primary material and the secondary production. So if there's a big difference, so for example, with aluminium, you've got a very huge difference between primary production and secondary, although it's not as big as some people claim. It's between, it can be as much as 50% of the, for the secondary material. It's not as low as 5%, as is often claimed, but it's certainly somewhere between probably 20 and 50% of the energy. For steel, again, there's quite a good, it's not as big a difference because the energy per kilogram of material produced for steel is much lower than for aluminium. But there are also practical limits on the current technology because of the current technology. So in 2017, one of our co-workers, Jonathan Cullen at Cambridge, Professor Cullen, developed a methodology for measuring and reporting circularity, and created a sort of circularity index, which is basically looking at the recovered end-of-life materials over the total materials demand, and then the secondary production energy and the primary production energy use. So these are both dimensionless figures, so you multiply one by the other and you get a figure. We looked at the industries, or some of the industries, not all of the industry. We looked at steel, aluminium, lead, glass, and paper, and you can see the figures. It's quite a difficult chart to understand, but essentially what we're saying is that the circularity of steel is a practical limit that you couldn't go more than 82%. UK potential is 77% with the current technologies that we have, but at the moment our circularity is at 12%. Globally, it's at 22%. Now that's an interesting challenge for the steel industry. You probably think that they're doing quite well, but obviously we can do a lot. The steel industry could do a lot better. If we look at the aluminium sector, the UK is actually doing rather better than the global average at 42%, but the potential is to get up to over 90%, and with the current technologies, UK could get to 90%, and even better if it could get to the potential limit. And similarly for the other industry, what was eye-opening for me was the paper, because actually the challenge with the practicalities of paper, that the current technologies will only give us a practical limit of 36% circularity. So we're always going to have some new paper by this measurement. But does that mean we've got the technologies wrong, or does it mean that we've got the materials resources wrong, and we should be making paper from other sources, or should we not be making paper in the way that we currently do it? And then we've got glass and lead with similar low practical limits for circularity. So if we then add that into our potential decarbonisation, we can end up with some figures. So we looked at the glass, metals, and paper side, and we found that we could get some. Paper was a challenge. It's really not a good thing to get circularity to create circularity, to create decarbonisation. Whereas metals and glass, you obviously can get some quite significant changes. In metals, you could get some really significant changes. And if you take into consideration circularity and best practice, we could potentially impact the metal sector and reduce the carbon footprint by 91%, which I think is phenomenal. So this is where we go with the metal sector. If you add the sectors together, if we add all those three sectors together, we can get a 70% reduction in those three sectors. And if we then actually move to all of the foundation industries, we could get potentially using circularity, we could get down to a 78% reduction from 27 megatons of CO2 in the UK to 6 megatons of CO2, which is a massive reduction. But if we actually then used clean fuels, in other words, decarbonized our energy systems, we could go down to a massive 97% reduction in emissions, which is really why we've got to go to electrical production and have no fossil fuels in our materials production. That's the message there. We did some process, so that's the end of the first bit of the work stream one. I can see the time is rushing past, and I'm going to have to skip through quite a lot of the next few slides and not go into quite so much detail. But just to give you an idea, I'm not going to talk about the process mapping, but we did a lot of process mapping, look at the individual processes for the manufacturing processes involved in the materials conversion into products. We then looked at this is work stream 2, where there's brass. So essentially what we were doing here is combining information from the models from work stream 1 with basic processes for production, investigate new and novel material chemistries and process technology to establish their viabilities as new routes for production. So we take the waste streams and the byproducts and the flows map, we identify waste materials that could be raw materials for other sectors, and then look at the processes by which they could be value could be added to the waste streams and the products, and including modifications to the parent processes, and see whether that reduces the carbon footprint and what is the reduced environmental impact. And then we need to develop some sort of hierarchical business models to see how much money is required to input or how much is required to enable this change to take place. And then, I'm not quite sure what happened there. And then we actually ran some workshops where we identified 350 synergies for new products from waste and 10,000 tons of waste diverted from landfill. So this was running 3 workshops, what we called them industrial symbiosis workshops. We got about 90 companies involved in these, or 90 sort of sites, not just 90 companies, 90 different manufacturing sites across the UK involved in these cross-sectoral networking and identified these potential synergies. It's interesting because we got people from across all of the sectors who would not normally have been in the same room. And as soon as you get people talking and sharing information, they suddenly realize what potentials there are for alternative sources of raw materials for their own processing. So in summary, for work stream 2, quite a lot of work was done in generating these interesting new products. And so the new products that we created was a composite material from waste plastic and into an alkyd paint and sustainable latex. And we created, I think, what you could say was an open approach to talking about products and processing between people who would not normally discover that there were synergies between their processes or their practices because they're from different sectors. We also looked at identifying the hidden value of mineral waste and gained a better idea of the understanding of the composition and the productions of the mineral waste across the whole of the UK. And we managed to also look at co-producing regional circular business models for industrial symbiosis. And the last work stream I wanted to mention, which I'll go through very quickly, this was driven by York Business School, York Stockholm Environmental Institute, and Edinburgh Science, Technology and Innovation Studies in the Social Sciences School, where we looked at metrics for the foundation industries beyond the fence, as we want to call it. So, and we mapped for resource co-location. So this directly feeds also back into work stream 2, because what we managed to do was to map all of our partners and our industries and the manufacturing sites within those sectors across the UK, and then see where there were co-located companies who might have potential for industrial symbiosis. Because one thing that you don't want to do necessarily is move materials very far when these are so-called waste materials, because that adds a cost to the process. Essentially, we know that foundation industries also use hot processes. So what's the challenge there? The glass industry, for example, was very focused on reducing temperature in industry. The technical working group essentially focused in reducing temperature and energy. But what they didn't really look at was, well, what about the waste heat that gets produced? What gets in the way, we wanted to look at, of them sharing that energy from the processing with the local community. And so we set up some meetings with people like the local authorities, with local industrial clusters, and wanted to find out what the challenges were for creating heat networks with industrial communities and industrial clusters and local communities. One of the studies we looked at was in Alloa and Alloa Glass, where there's a glassworks, there's an air products chemical site, there's Fourth Bank Industrial Park, there's an abandoned mine shaft from the Coal Authority, there's wastewater treatment facilities with the Scottish Water Horizons, we've got the Stirling Clackmannanshire Regional Energy Master Plan, and although heat networks in that plan is a local priority, there's no mention in it of using industrial heat, because they don't believe that's in their jurisdiction. So one of the things that we did was we created the ability, or we opened the door to this regional network and the councils to talk together and work with Owens Illinois manufacturing company who make glass, and these other manufacturers and the local community. And at least we've opened the door. That's all I can say. I think we've been successful in starting the conversation, and that's one of the most important things. We tried to do the same with the only remaining primary aluminium company in the UK, Alvance, up in Fort William. But the local planning community, despite their local planning council, despite there being no gas in Fort William, there's no piped gas in Fort William, so everything is either oil shipped in. So domestically, you either have electrical heating or you have oil heating. There's no gas supply in Fort William. So despite the fact there's a lot of energy that's wasted in the primary aluminium plant in Fort William, the local community or the local planning people were rather reluctant to look at even or thinking about having a heat network which would involve a pipe coming down quite near Ben Nevis across the Caledonian Canal into the centre of Fort William, and providing a number of homes with essentially free heat. Because it had to go across a railway, a canal, and a road, and that was their biggest challenge. So unfortunately, we've got sort of social things that we need to look at as well to be able to answer some of these problems. So in terms of the outputs from workstream 3, we got engagement with multiple stakeholders across the UK. We looked at mapping all the contacts and the assessment of location of potential opportunities for things like heat, power, and skills. And then we looked at the barriers, and I've mentioned some of the barriers there. We did, yes, of course, we did promote sort of peer-to-peer learning and what we call user journeys, and we really managed to open the eyes of some of the policy enablers as well, which was quite good. I just wanted to say that these are some of the main case studies that we did. One was called 1,000 Cuts, which was looking at materials production by tiny little changes. Another one was looking at a new green copper refinery. We looked at the composition of glass and how that can change the amount of heat that you require to melt your glass. We looked at optimization of ceiling tile manufacture, and then also the opportunities within the wind energy sector, and also Celsa steel, some byproducts. I'm not going to go into any details on there, but apart from the fact that I wanted to just show you the glass furnace temperature work very quickly. And this is an analysis of a number of different glass manufacturers. These are container glass, flint container glass. So this is transparent glass, not amber or green glass. And this is for a number of sites, as you can see, 10 different sites, 8 in the UK and 2 in India. And the compositions look the same, but they're not. There are some subtle differences in the amount of silica, the amount of the balance between silica, alumina, iron and calcium. And those differences make, and magnesia, I should say, those differences, those little differences make a significant difference to the melting point of the glass, or the processing points of the glass. And doing an advanced principal component analysis with all these factors, the batch cost, the fuel cost, the output, the quality, the furnace lifetime, and the amount of cullet, and the consideration of emissions, this work developed a tool whereby you can look at these things, and actually, if you look at the figures on that previous chart, then the first column was the one that gave the lowest or the best figures for all of these figures. So F01 in the UK. So the take-home message for our glass manufacturers was that they can reduce their furnace temperatures slightly by changing the glass formation, which means that they can make it cheaper with less energy, with fewer emissions. And of course, it's not very risky, because there are actually people who are already doing this. The whole paper, which is identified at the bottom of this slide, is actually published, and that actually goes into green and amber glasses as well, not just the transparent glasses. Another interesting one, which I'm just going to briefly mention, was the characterization of steel mill byproducts from Celsa through Cardiff University. And this was a mineral site in Cardiff, or in Wales, where they stored various byproducts from Celsa manufacturing. And the source of the materials was the smelting of steel scrap, and various added materials from the rebar section. So the materials that they ended up with, the waste materials, are black slag, white slag, electric arc furnace dust, quench tower dust, mill scale, lubricant materials, and what they call day down materials, the materials that are when they shut the material, when they do a refurb, those materials, and then the road sweepings themselves. And the whole program was to look at the elemental and mineral compositions, assess the physical characteristics and particle size distributions, and then explore the applications of potential for recycling. So this is really looking at the environmental impacts. It promotes waste reduction and mitigates environmental contamination through sustainable byproduct management, economic advantages by opening new revenue streams from the byproduct recycling, and it reduces the landfill costs. It gives you some industrial innovation, because it leads to some byproduct utilization and methods, and supports the circular economy in steel manufacturing, but it also gives us some materials understanding, and is a collaborative progress, because it's encouraging academia, industrial partnerships, and driving innovative recycling and reuse methods. Lastly, I want to talk about the ED&I. So this was led by Professor Sue Black from Durham University, who's actually a computer scientist and what she calls a technology evangelist. She wrote the book Saving Bletchley Park. If you haven't read that or know about it, I sincerely promote that as something you perhaps should look at. It wasn't Alan Turing who did most of the work. It was really 80% of the workforce were women at Bletchley Park, who were doing a lot of the code breaking. Although obviously Alan Turing was very important to that, he wasn't the only person working on the code breaking. Anyway, so Sue led this work stream, or this activity, reviewing best practice, designing an ED&I strategy, reviewing the skills requirements in the foundation industry, and looking at how we might attract people into STEM careers. And it's quite easy. It's quite simple. You start by listening, look to the future, engage industrial leadership, establish goals, measures, and targets, and set foundations for the industry culture that's attractive, inclusive, and that attracts inclusive and diverse talent. So the outcomes were that there was a strategy which was drafted. There's a playbook that's been produced, and we had a series of podcasts, 8 podcasts, which are available to download from your favorite podcast provider, whether it's Spotify or any other. And this was the Equity Edge podcast. They are very interesting. I would advise that you have a look at those. The link is there, and I'm sure we can publish the link to in some way through the founders. And actually, the last thing, which was to look at a metric, so industries can actually do a measurement and actually find out how mature they are in their ED&I behaviour throughout their plant. So, if we look at the summary of what Trans5 have actually done, we created 25 new jobs. We won 42 awards. We did 157 invited talks, 27 engagement, policy engagement and impact activities. We created another £30 million plus of funding for the companies that were involved. Of our staff, and 5 of them got promotions and 9 of them ended up somewhere else. We created 130 odd partnerships. We got £5 million of co-investment from industry, and £1.3 million of that was cash. Lastly, but not least, was the impact on what we were trying to do, which was impact the climate change. So these are the measures that we believe. There's two. The figures are there. The big figures are important, but the justification of those figures is in the small writing. So if we publish these slides, then you'll see that. And if you download the report, these are in the report as well. And I just wanted to show this as a bit of not a joke, but it sort of shows you how complex the interactions were across the network. So there's Transfire in the middle, and these are all the different work streams, all the different industries, all the different players, all the different activities. Now you can see why I had a headache for 3.5 years. Thank you very much.
Thank you, Mark. Yeah, obviously, clearly a huge undertaking there. And lots of aspects to it, but all hugely important. Talking of podcasts, I did note that there's the BBC Sounds have just put one out on the Briefing Room series. One of their explainers is on rare earths, only 7 minutes long. So if anybody wants to have a bit of more of an understanding, because obviously people talk about rare earths, but they're actually not always that rare. It's a bit of a misnomer, and but
Tom Heap actually did a podcast or a whole program on rare earths a couple of days ago.
Sorry, say it again.
Tom Heap. And
there's been a few books and series in there, but
it's very interesting.
Literally, the Briefing Room have put out another one very recently as well. I say we are pretty much out of time. There is I can see a hand up, but before I come to John, there's just a note in the chat about material circularity. Somebody asking for another lecture on it, so I think we can take that on board as founders. I mean, I think the foundry industry, well, we would say we're right at the heart of this, or right in the middle of it, because we take a lot of the metal that goes otherwise into the scrap industry, comes back into our industry, and then we recycle it into new products for a huge range of applications, as many of you will know, which again then can be recycled at the end of life. Obviously, steel has been in the news. There is a big change to the dynamics of the secondary steel market because of the move to away from blast furnaces in favour of arc furnaces. I mean, I've heard conflicting things, but I think on the whole, most of the things that we need, we can make in this country, and we're a net exporter of scrap steel. So actually making it here is better, because otherwise there's the risk of what's called so-called exporting our carbon footprint. Would you broadly agree with that, Mark, or are there certain
Well,
grades
there
that
are two, there are two aspects.
we can't
Yeah, no,
make?
there are two. Yeah, there are two aspects to that. Yes, definitely, there's a business opportunity that we shouldn't be exporting 8.5 million tons of scrap steel and then importing 5-6 million tons of other steel. We were importing about that, and then we were producing about 6 million tons of steel, of primary steel here ourselves. Well, we don't necessarily need all that primary steel because we exported 4 million tons of it anyway. So we're exporting 4 million tons of primary steel and 8.5 million tons of scrap. We could have been dealing with that within the UK. What we probably do need is, I mean, and I think actually Sarah Jones, the business secretary, got this right, because she talked about the fact that we're saving the blast furnace at Scunthorpe temporarily. It may be 5 to 10 years. And she did get that right, because we do need to shut that down, because it's obviously got a very high carbon footprint. But we can, as long as we're doing the development on a new process, which is direct reduction of iron ores to produce steel directly, rather than going through a 300-year-old process, which is, cast iron. And then, so cast iron is obviously, we know as foundries that it's got about 4% carbon in it. And then we take out the carbon to make steel by pumping in oxygen, which was the Bessemer process developed in 1856. So combining our technology of 300 years ago with our technology of 150 years ago, we're still making steel that way. Whereas there are better ways now, direct reduction of steel from hydrogen. The challenge being, where do we get the hydrogen from? Or is ammonia a better reducing gas? Or is there some other combination of plasma, hydrogen, ammonia? There's a lot of work being done at the Max Planck Institute in Germany on this. And I'm not an expert in this area, but I know that's the way we should be going.
I think you touched on electricity and electrification, perhaps I should say more specifically, which is moving away from reliance on fuels, other fuels like oils and gases and things like that. That is a challenge, but I think it's also an opportunity, which is why things like wind, solar and offshore wind and all sorts of other things are important, because we do need to move to electrification, but ideally not electricity that's been generated from fossil fuels. And I think there's a lot of investment going in there. We are over time, but John, I'll come to you with a question, if I may. You've got your hand up.
I assume that's John. I assume that's John
Wood. Yeah.
Yeah. He doesn't have his camera on.
Are you there, John? He's probably gone off to get his tea or something.
I know he's there.
Hello,
he's just in the dark.
Yeah. We can't hear you, John. So I think you can see you now, but in the gloom, but we can't actually hear you.
Your microphone isn't working.
Yeah, it's obviously you're unmuted, but we can't hear you, unfortunately. So sorry about that, for whatever reason. Oh, how frustrating for you. Yes, I can imagine. But unless you can quickly type it in the chat, otherwise we'll just
type it in the chat, John. Then
yeah, if you can type quickly. Just while we're just sort of wrapping up in time. I mean, I'd say we are.
Can I make a comment about the electrification? It was really interesting.
Yes.
We had a metals working group webinar, which I organised for the metals working group, where I got a Swedish company to come in and talk about making steel only using electrical energy. I was challenged by Cardiff University academics to say this was ludicrous. It couldn't possibly happen anywhere. And I said, well, no, you're wrong. I said, it's being done in Sweden. They don't have piped gas into this steel company. It's Uddeholm, and they make high quality steels. They do annealing, they do heat treatment using electric furnaces. They use radiant furnaces, not RF. And of course, all the electricity in Sweden is sustainable. It's all either wind or hydro or geothermal. So they're totally sustainable electricity. And I think the challenge, when the academics don't believe that the technology is available to do it, that's where we've got a bit of a challenge. But that academic came back to me and said, I eat my hat. Yeah, I agree. It is possible, but the challenge, of course, is the economics.
Yeah, and of course, as we keep shouting in this country, sometimes on somewhat deaf ears, the biggest challenge in all of this, and for manufacturing and the metals industry, is the price of energy in the UK, which is, in spite of the fact that 40 to 50% of it is now from sustainable and renewable sources.
It hasn't reduced because it's all based on the gas.
Ought to be cheaper. Once because there is an investment obviously in that, but that so anybody that you're talking to, please make that point very firmly and loudly, that the biggest thing that anyone could do who's got any levers of power is to reduce the price of energy in the UK wholesale, and that would help us be a lot more competitive per se, for the whole of the industry basically. So I think John was asking about real outcomes. I mean, you've obviously handed the baton on, Mark. Do you want to make a comment or two about who's picking this work up? I mean, there's so much work going on. It'd be hard to sort of list everything, I think, in less than a few hours.
Well, unfortunately, the UK government and funding bodies through UKRI doesn't work in a strategic way. So what they do is they put together an idea that, yes, this work should be continued. Then they put out a funding call and make a competition out of it. And it goes to a panel who may or may not be convinced that what you're doing is useful or valuable, despite the fact you might have 60 or 70 industries supporting you. So that's what we did. We put a funding call together with Imperial College, with Surrey, Exeter, Strathclyde, and Heriot Watt, covering all the funded sectors on industrial decarbonisation, National Institute for Circular Economy Research, and the Transforming the Foundation Industries Research. We put that proposal together called Sustainable Industrial Futures Unlimited, £18 million for 7 years, which is peanuts. It's not enough, to be honest. And we didn't get the funding because we were up against 3 other groups, one of whom obviously was liked better than ours.
Yeah.
Rather than thinking strategically, why don't we just bring
and building
together and building on what we've already done and making it
very frustrating, isn't it? I mean,
it's very frustrating.
We're all hoping for an industrial strategy that can make a difference for our sector. But I mean, at least that we can say that there's a lot of discussion in this area, and people are talking about metals and materials a lot more than they ever have done, recognising their strategic significance. We've got a few MPs in the House now who recognise that as well.
Yes,
so we could be reasonably optimistic if we wanted to be so. So, Mark, on that note, I'm conscious we've run over time. Thank you very much for covering a huge topic in a short space of time. I think it's something we'll be revisiting, because obviously it's something that's hugely important, and I think a lot of our young student bursaries and the sponsored projects that we're supporting, a lot of these are covering all these sort of topics as well. Our next lecture is, we leave it for the summer, but we're back. Our next online one is in November, 18th of November, and it'll be on glass. Now, obviously, Sarah Harold, who's our lecturer then, was very involved with Mark and is still very much involved in glass futures, but also lots of other initiatives as well around the foundation industry. So I'm hoping that'll be a really interesting and a very relevant follow-on, actually, from what Mark has spoken about, because that'll take us another 6 months down the line, and we can see how things are progressing. So thank you all for joining tonight. I hope to see many of you at events in the hall over the summer and into the autumn. And as I say, hopefully on the 18th of November, look out for publicity as well. Thank you again. Thanks also to Eloise for facilitating tonight. And I'll see you all again soon. Good night.